All right, ladies and gentlemen. So what we are going to do today is we are going to go through naming covalent bonds. So they're going to be a little bit different from naming ionic bonds. There are going to be a couple similarities, but there is a difference, and that's going to be these things called prefixes that we're going to get to today. Before we get started, I do want to tell you guys that there is a naming ionic check for understanding on Canvas. So I want you guys to do that after we're finished with this introduction activity on Canvas, because this should not take the whole period. You should have some time to work afterwards. So covalent compounds are made from two nonmetals. That's something big that we got to remember because there is that difference, and we do need to eventually identify between ionic and covalent compounds for naming, for drawing, for coming up with formulas, all that good stuff. So we do need to be able to identify nonmetals and metals. Then covalent compounds are going to use those prefixes to show the number for each element that's present. So we have 10 prefixes, and these 10 prefixes, I'm not going to say you have to memorize because, again, we're online. If you have them up in the corner every time you're taking the test, I can't tell. But it should be something that you try and remember, because if you have to keep going back and forth between this and your test, it might lose enough time where you might run out of time before your test is over. So I wouldn't recommend that you just like ignore them completely. But if you can try and remember them as best you can, that's always better. So if we look mono and di, I really don't have much to tell you about. We're trying to remember them. But then like once we get to try and think of something like a triangle has three sides, or a tricycle has three wheels, which is how you can remember that three means try, or that try means three. Tetra, if you think of the game Tetris, where you're building those blocks and you're trying to get rid of them, each Tetris piece has four blocks that you're trying to put together. So four means tetra, like Tetris. The rest of these, try and think of things like for five, a pentagram or a pentagon has five sides. A hexagon has six sides, so hexa means six. A heptagon has seven sides. An octagon is like a stop sign, which has eight sides. A nonagon, which has nine sides, it's a shape. And a decagon has 10 sides as a shape. I promise those are real shapes too. I'm not just making things up to try and get you to remember those names. Or for deca, you could think of the word decade, which is 10 years. So that's another way of trying to remember 10. Again, you don't have to have these memorized, but if they do stick in your memory, it will be easier for you in the future. These prefixes are the big difference between ionic and covalent naming, besides the fact that ionic has metals and covalent's only nonmetals. These prefixes are going to be that huge difference between them because we need to add these prefixes to both of our elements. So these rules for naming or writing the names for these ionic or covalent compounds are going to be important. So the first non-metal, or the first element in a covalent compound, you're going to add a prefix as long as that prefix is not one. Never add the prefix for one on the first non-metal. So we never add the prefix for one on the first non-metal, because if you just write the element's name, it's telling you that there's one of them. And if you put a prefix in front, that's when you're looking at more than one. So if we look at these two examples showing you that, example one, we can see that this is nitrogen. And then we can see that it's telling us there's two of them. That prefix for two is the di right here. And then we have the element name nitrogen after it. The other thing you should notice is there's no suffix added or there's no change. So you're not getting rid of the OGN and adding the IDE here. You're not changing the ending. You're just writing the element's name and then putting a prefix in front. The second one, how many carbons are present here?
One.
Just one, because there's no number, meaning one. Which is why there's no prefix in front of our carbon, because there's only one, so no prefix. Any questions so far on this? All right. So our second nonmetal or our second element is going to do some of the similar things as our ionic bonds. We are changing the ending to IDE every time. So no matter what kind of bond you have, whether it's an ionic or a covalent bond, you are always changing the ending of the second element to IDE. But for covalent compounds, we are going to have a prefix. So always use a prefix. I don't care if it's 1, if it's 2, if it's 12, if it's 100, you're always using a prefix. So for this first one, how many oxygens do I have?
One.
1, which is why we have the prefix in front of oxygen as mono. And then that's why they've changed the ending of the second element to be IDE to show that it is the second element. Same thing with this second one. They've changed the ending to IDE. And then how many oxygens do I have here?
2.
2, which is why we changed the prefix to di for dioxide or 2 oxygens. Are there any questions on the rules? Because we're going to do some practice together. But any questions on the rules? All right. So then what's going to happen is let's take a look at our example. So we have P2Cl6. So my first question is, what is the element P?
Phosphorus.
Phosphorus. And then what is the element Cl? Chlorine. Good. Do we need to change the ending of phosphorus or chlorine?
Yeah.
Which one? Or both?
Phosphorus.
Both.
Because it has 2.
Change the ending. The end.
No. Don't you
But
change the beginning?
we got to change the beginning. But before we do that, do I have to change the ending of phosphorus?
No.
No, because it's the first element. We don't touch the ending. We keep it the same. What about chlorine?
You do the ending of chlorine?
We got to change the ending of chlorine. And what do we change that ending to?
IDE.
IDE. So I'm going to take off the INE and add an IDE. So it's going to be chloride. Perfect. All right. So now the prefix time. Do I have more than one phosphorus?
Yeah.
So do I add a prefix?
Yeah. Isn't it di?
It is di for 2. Perfect. What about chlorine? What's my prefix for chlorine going to be?
Hexa.
Hexa. Perfect. So now we're going to put these things together. So let's put the prefix in front of our phosphorus. Let's put it as one word. So what is that one word going to read as?
Phosphorus. Hexafluoride.
Diphosphorus. And then my second one, I'm adding the prefix in front of this. So what is my second word going to read?
Hexachloride.
Hexachloride. So I have diphosphorus hexachloride here as my compound's name. Are there any questions on that one? All right, let's do one more together. So we have The first element. What is that first element?
Nitrogen.
Nitrogen.
Nitrogen. Do I need to add a prefix in front of this nitrogen?
No.
Because it's only one.
Because there's only one and we don't add a prefix if there's only one for the first element. What's my second element?
Oxygen.
Oxygen. Do I need to add a prefix in front of oxygen?
Yeah.
Yeah.
What is my prefix going to be?
Try.
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 Right, perfect. Do I have to do anything else?
Yeah. You need an
IDE.
ending to oxygen.
All right, I got to change my ending to what?
The
IDE.
ID.
IDE, perfect. And we're going to put that right next to nitrogen. So trioxide. So nitrogen trioxide. Any questions? You guys think you can try 3 and 4?
Yeah.
All right. Take about, let's go 2 minutes and try 3 and 4. All right, let's go through these 2. So did anybody come up with that first one?
It's disulfur tetraoxide.
Does anybody disagree with that one? All right, perfect. We're crushing it. What about number 4?
Selenium pentachloride.
Awesome. Does anybody disagree with that one? All right, nice job, ladies and gentlemen. If you did not get those and you have questions about that, please let me know. Otherwise, we're going to keep going on to our formula writing. So we're going to go the opposite way now, just like before. So with formula writing, I'm actually going to change the wording up here a little bit because it should say that covalent compounds form bonds. So we're going to get rid of this do not. But covalent compounds form bonds. So formulas are not based on the charges anymore. That's why we're going to need to write those prefixes in front, is because those covalent compounds are not based on charges. They're based on how many we have. So then we need to write these formulas. We need to use the subscripts are going to be based on those prefixes that we use. So this carbon, if there's no prefix, how many carbons do we have?
1.
1, perfect. And this prefix right here means how many of this oxide?
1.
1.
1. Perfect. And then remember, this oxide is really just the ox, and we got rid of the IDE, and we can add back our previous, our previous ending, which should be YGEN for oxygen, making it 1 carbon and 1 oxygen. So let's go through a practice problem or two together. So let's look at our element. The first word, what is the element from that first word?
Nitrogen.
Nitrogen. Perfect. And nitrogen is N. In this prefix in front of that first word, it means how many of them do we have?
We have 2.
2.
2.
We have 2. Perfect. So that 2 becomes our subscript down here. Now the second word, what element do we have from that second word?
Oxygen.
Oxygen, because we have oxide, so it's really oxygen, in which is the element symbol O. And how many oxygens do we have?
7.
7.
7 from hepto. 7. Any questions? All right, let's do one more together. Carbon tetroxide. What element do we have here?
Carbon.
All right, we have carbon, and how many carbons do we have?
1.
1. Do I need to put a 1 below?
No.
Nope. And my second element for my second word, what is it?
Oxygen.
Oxygen. And how many oxygens do I have?
We have 4.
We have 4. Perfect. Any questions on that one? Real quick, I do want to note that tetroxide is how it should be written, because the A from tetra gets taken away because the A and the O next to each other is just not grammatically correct. So it got taken away when they wrote tetroxide. So that's why oxygen, there's no A in front of any of the oxides, because they all got taken away. But if you write them as tetraoxide, it's not going to be marked wrong. All right, you guys got 3 more to try on your own. We'll go over them in 3 minutes.
Don't read the comments. It will spoil the very satisfying ending.
All right, so let's look at that first one. Trichloride monoxide. I'm sorry, guys. This should have said not trichloride. It should be trichlorine. Man, apparently I messed up. So it should be trichlorine monoxide, but that shouldn't have changed your compound. So what is my first one?
CL3.
CO3.
Oh.
Oh, CL3O. Any questions on that first one? All right, number 4. What is my compound for number 4? What's my formula going to look like?
NCO9.
Perfect. Then what about that last one?
PO4.
You said P? What?
PO4.
PCO4. Any questions on any of these? All right, ladies and gentlemen, that was everything I have for you on this worksheet. So just go ahead and work on that ionic naming, check for understanding, and then you are all done for the day.